All right, teachers, it's March Madness basketball, but also March for our latest math fix. Please take a look, let us know what you think and how you're using them in your classroom.
Today's math fix centers around 2.g.3, partitioning circles and rectangles into 2, 3, or 4 equal shares, describing the shares using halves, thirds, half of, third of, and etc. The standard also says recognize that equal shares of identical wholes need not have the same shape. This math fix is all about the last sentence, a take on recognizing that equal shares of identical wholes need not have the same shape. In this math fix, we're talking about equal shares within a single whole, not having the same shape. In this task, students will work to prove whether or not the fourths named inside the square truly are fourths. Many, perhaps most students, may quickly say, no, the square is not partitioned into fourths. Those pieces are not equal. They will stop after this assertion. They will need reminding that they are expected to prove it. This is where the misconception first reveals itself. Many of these students will say the shapes are not the same, so the square is not partitioned into fourths. If you want to push their thinking, have two drawings prepared. In the first drawing, we have the same square partitioned into fourths using squares, like the right side of the shape. In the second drawing, have the same square partitioned into fourths with all 4 rectangles, like the left side of the shape. Show the first drawing and ask, is this shape partitioned into fourths? The students may likely say yes this time. Show the second drawing and ask, is the shape partitioned into fourths? The students may answer again yes. Then point to the original shape on the paper and ask, so is this shape partitioned into fourths? And then walk away. Students that already understand that the shape is partitioned into fourths may still need to prove it. Some may use the reasoning already presented, that if one square partitioned into fourths looks like this, and the other looks like this, then the given one must be partitioned into fourths. Other students may try to match the area without knowing what to call it. These students may ask for scissors. They'll cut out one of the rectangles or squares and further decompose it into new composite shapes, the other one in the picture, proving that each piece is 1/4 of the large square. In terms of solutions, yes, each piece is 1/4 of the square, or the square is partitioned into fourths. It's all about the end of the standard, recognizing that equal shares of identical wholes need not have the same shape and applying the knowledge in a new way. See if you can get your non-believers to change their mind on their own with the questioning shared earlier. You can even do this with other than fourths in a square.
That's it, teacher. That is our math fix for March. Hopefully you enjoyed it. Looking forward to hearing how you and your students engage with it. Leave us a like or a comment below, and we'll see you again next month.